Hello friends, welcome to my channel. This is where we learn mathematics. We are going to learn about matrices, definition of matrices, examples of matrices, and the order of matrices. Definition of matrices, examples of matrices, and the order of matrices. If you are new to this channel, kindly subscribe and open notification bell so that you will be notified for the next video. Let's start our tutorial. Definition and examples of matrices. A matrix is a rectangular arrangement of numbers, expressions, symbols, which are arranged in rows and columns. Here, these numbers, expressions, and symbols are called the elements of a matrix. We have examples. There is a matrix A, matrix B, matrix C, and matrix D. In matrix A, we have A, B, C, D. These are arranged in rows and columns. This is the first row, the second row, and this is the first column, and this is the second column. So they are arranged in rows and columns, forming a matrix A. This one. For matrix B, we have numbers. We have 1, minus 1, 3, 0, 3, 0, 2, 3, and minus 4. And these numbers are arranged in rows and columns, forming a matrix B. For this matrix C, we have also numbers arranged in rows and columns. So this is a matrix. In D, we have cosine theta, minus sine theta, and cosine theta. These elements are arranged in rows and columns, forming a matrix D. So generally, a matrix is a rectangular arrangement of numbers, expressions, symbols, which are arranged in rows and columns. So let's see order of matrices. The number of rows and columns of a matrix is called its order or its dimension. So what we call the order is the number of rows and columns of a matrix. By convention, rows are listed first and the columns second. We have example. State the order or dimension of the following matrices. We have matrix A and matrix B. For matrix A, we have elements 1, 3, 4, 2, minus 2, and 0. To identify the order of this matrix, first of all, we identify the rows and columns. Then the order would be the number of rows and columns of this matrix A. So for this matrix A, there are rows, this row, and this one, 2 rows. And for columns, we have this column 1, this second column, and the third column. 3 columns. Thus, the order of this matrix A is 2 by 3. And this means the matrix A has 2 rows and 3 columns. Next is the matrix B, this one. Let us identify rows. We have this row, this one, and this one, 3 rows. And the columns are first one, this one, the second column, and this third column. So this matrix has 3 rows and 3 columns, and the order is 3 by 3. As you can see, the matrix A has 2 rows and 3 columns, and matrix B has 3 rows and 3 columns. For the matrix A, the number of rows and columns are not equal, and for this matrix B, the number of rows equals number of columns. This results in the following notice. If a matrix has n rows and n columns, meaning that the number of rows and columns are equal, then it is said to be a square matrix of order n. Examples: a matrix 2, 0, -1, and 4. This one is a square matrix of order 2. This is because this has 2 rows and 2 columns. The number of rows and columns are the same. So this is a square matrix of order 2. Next, a matrix, this one, 1, 0, -6, 2, 4, -2, 3, -1, and 9 is a square matrix of order 3. This is because the number of rows and columns are equal, and this number equals 3. That's why this is a square matrix of order 3. Thank you very much for learning. This is the end of the video. See you in the next video. Thank you very much.